In this problem, we're given that the sine of alpha is 3/5, where the terminal side of alpha is in the first quadrant. We're also given that the cosine of beta is 2√5/5, where the terminal side of beta is in the fourth quadrant. We want to find the sine of alpha plus beta, the cosine of alpha plus beta, and the sine of alpha minus beta. To do this, I need to first figure out the cosine of alpha and the sine of beta. To find the cosine of alpha, I'm going to use the fact that sine squared of alpha plus cosine squared of alpha equals 1. Or cosine of alpha is the positive square root of 1 minus sine squared of alpha. Why the positive square root? Because the terminal side of alpha is in quadrant 1, where the cosine function is positive. So I get that that equals 1 minus the square root of 1 minus 3/5 quantity squared. And if I work this all out, I get that the cosine of alpha is 4/5. Now I also need to know the sine of beta. Notice that beta is in quadrant 4, where the sine function is negative. Therefore, the sine of beta is going to be the negative square root of 1 minus the cosine squared of beta. So I have negative square root of 1 minus 2√5/5 quantity squared. If I work this all out, I get that the sine of beta is negative √5/5. So now what we want to do is keep track of the values of sine of alpha, cosine of alpha, sine of beta, cosine of beta, so that when we substitute into the sum and difference formulas, we know where these results come from. In part A, we want to know the sine of alpha plus beta. My recommendation is this: when you're working these problems out as homework, write out what these formulas are equal to first each and every time, so that as you're working these problems out, you end up accidentally memorizing the formulas. So the sine of alpha plus beta is the sine of alpha times the cosine of beta, plus the cosine of alpha times the sine of beta. Remember, the sine of alpha is 3/5. The cosine of beta is 2√5/5. Plus, the cosine of alpha is 4/5. The sine of beta is negative √5/5. So 3/5 times 2√5/5 is 6√5/25. Then we're going to have a minus 4√5/25. 6√5/25 minus 4√5/25 is 2√5/25. Next, I want to determine the cosine of alpha plus beta. Well, the cosine of alpha plus beta is the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. Recall that the cosine of alpha is 4/5. The cosine of beta is 2√5/5 minus the sine of alpha is 3/5. The sine of beta is negative √5/5. So here we have 8√5/25. Two negatives make a positive. 3√5/25. Adding, we get 11√5/25 is the cosine of alpha plus beta. Lastly, we want the sine of alpha minus beta. The sine of alpha minus beta is the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. Well, the sine of alpha is 3/5. The cosine of beta is 2 root 5 over 5. Minus the cosine of alpha is 4/5. The sine of beta is negative root 5 over 5. Multiplying this out, we get 6 root 5 over 25. Multiplying this out, we get plus 4 root 5 over 25. Adding, we get 10 root 5 over 25. There's a common factor of 5 that we can divide out, and we get 2 root 5 over 5.